The outer solar system is a realm of profound and silent mysteries. We are about to journey beyond the asteroid belt to uncover 30 of the most bizarre events ever recorded. By the end, you will possess a new understanding of our cosmic neighborhood, one filled with active worlds and phenomena that challenge everything we thought we knew. How can a storm on Saturn form a perfect hexagon large enough to swallow Earth's? What force causes icy volcanoes to erupt on a frozen dwarf planet? The answers reveal a solar system far from dead, but teeming with strange and dynamic life. What does it mean for our place in the universe to find such wonders in the darkest cold? Floating above Saturn's north pole is a geometric wonder so vast it defies belief. A perfect hexagon etched into the atmosphere by a raging jet stream has held its shape for more than 40 years. This is not a fleeting cloud formation. It is a permanent planetary scale feature, a whirlwind of gas with sides longer than the diameter of our entire world. You could drop multiple Earths inside this storm, and they would rattle around like marbles in a colossal spinning jar. The Cassini spacecraft gave us our first clear views of this impossible structure, its cameras revealing a six-sided vortex churning in endless polar darkness. How can nature, which so often favors curves and chaos, produce something so rigidly geometric? Scientists believe the answer may lie in the physics of fluids. When fluids of different densities or speeds interact, they can create standing waves, patterns that lock into place. Think of the way a guitar string vibrates at a fixed frequency to produce a specific musical note. The hexagon might be a similar kind of atmospheric wave, a fundamental vibration of Saturn's deep and turbulent air, amplified to a staggering scale. Yet this elegant theory only deepens the puzzle. Why six sides? Why has this specific pattern remained so stable for decades while smaller storms on Saturn come and go? The hexagon stands as a silent, rotating monument to the forces we have yet to fully comprehend, a symbol of the beautiful and orderly mysteries waiting in the dark. From the geometric perfection of Saturn, we travel to the frozen edge of our planetary system, where another discovery shattered our expectations. The New Horizons spacecraft revealed a world we once thought to be a static, frozen ball, but Pluto is alive with strange geology. Among its most astonishing features are great mountains that do not look like any volcano we know. They are cryovolcanoes, ice volcanoes, and they may still be active. One of the largest is called Right Mons, a towering mound over 4 kilometers high and stretching 150 kilometers across. Its summit is not a sharp peak, but a deep, depressed crater, and its flanks are wrinkled with strange, lumpy textures. This is not a mountain built from molten rock, but from a frigid slurry of substances like water ice that acts like rock, mixed with potentially softer ices like frozen nitrogen, ammonia, or methane. Imagine not fiery lava, but a slow, oozing glacier of slush creeping up from the dwarf planet's interior, freezing as it reaches the unimaginably cold surface, building a mountain over millions of years. This process completely upends our idea of what a geologically active world requires. For a volcano to work, you need an internal heat source, something to melt the material so it can rise. We understood this on Earth and even on Jupiter's fiery moon Io. But how can a small, distant, and bitterly cold body like Pluto generate enough internal warmth to power these icy eruptions? The answer might lie in the slow, radioactive decay of elements deep within its core, providing just enough energy to keep a subsurface ocean of slushy, salty water from completely freezing solid. The existence of Right Mons suggests that Pluto, far from being a dead relic, has a complex and warm heart, a place where the chemistry for life's building blocks might still be stirring in the dark. What other frozen worlds at the edge of our solar system are secretly stirring with this same slow, icy life? Even Saturn's grandest architecture is subject to strange and fleeting graffiti. Across the vast, flat plains of its rings, dark, radial features occasionally materialize like the spokes of a phantom wheel. These are the ring spokes, one of the solar system's most transient and puzzling phenomena. They can stretch for thousands of kilometers over the ring material, appearing as dark smudges or, at times, bright streaks against the icy backdrop. They form with startling speed, then fade away after just a few rotations of the planet, as if some invisible artist is sketching on the rings and then immediately erasing the work. For a long time, we only had fleeting glimpses of them from the Voyager probes, making them seem like cosmic mirages. It was the Cassini mission that confirmed their reality, yet their true nature remains wrapped in mystery. So what are these ghostly spokes made of? The leading theory suggests they are clouds of incredibly tiny ice dust, particles finer than smoke that have become electrically charged. This charge levitates them just slightly above the plane of the larger, older ring pieces, making them visible as a separate, shadowy feature. But what force could lift this dust? The answer seems to be tied to Saturn's powerful magnetic field. The planet is a giant magnet, and its magnetic field rotates with the planet's interior. The countless tiny ring particles, however, orbit at speeds dictated by gravity, which changes with distance from Saturn. This creates a complex and dynamic interaction. Scientists suspect that when the conditions are just right, perhaps influenced by solar storms or shifts in the magnetic field, electrostatic forces can suddenly launch this fine dust out of the ring plane, creating a spoke. The greatest puzzle is their sporadic appearance. Why do they vanish for years, only to reappear in a flurry of activity? This suggests a delicate balance of forces, a cosmic recipe that requires ingredients we have not yet fully identified. It is a reminder that even the most stable-looking systems in our solar system are capable of sudden, beautiful, and unexplained flickers of change. Far from the ghostly spokes of Saturn's rings, another of its moons presents a landscape that is hauntingly familiar and utterly alien. Triton is a world shrouded in a thick, orange haze, where rivers carve valleys into icy bedrock and great lakes dot the coastline. But these are not bodies of water. On Triton's surface, which is colder than -170 degrees Celsius, the rock is water ice, hard as granite, and the flowing liquid is methane. This moon has its own version of Earth's water cycle, a complete meteorological system where methane takes the starring role. It evaporates from the lakes, forms clouds in the dense nitrogen atmosphere, and rains back down to fill the rivers and seas once more. This creates the only other world in our solar system with stable liquid on its surface, a truly Earth-like process playing out with a completely different set of ingredients. The Cassini probe, using its radar eyes to pierce the opaque haze, mapped these methane seas. Some are as vast as the Great Lakes of North America, while others are smaller, scattered pools. But these lakes do not behave as we would expect. Radar images taken at different times have shown bright, island-like features that appear to vanish between observations. One moment, a patch of land is visible in the middle of a sea, and the next it is simply gone. These are the Phantom Islands, and their fleeting nature points to a landscape in constant, slow motion. So what could they be? They might be fields of bubbles, vast collections of nitrogen fizzing up from the seafloor like the carbonation in a soda. They could be floating solids, perhaps great sheets of porous, frozen hydrocarbon foam that rise and sink with the seasons. Or they could be literal waves, not of water, but of methane, with troughs and crests large enough to be mistaken for solid land by a passing spacecraft. The very possibility of waves on Triton is a thrilling and perplexing idea. For waves to form, you need wind to blow across the liquid surface. Triton's atmosphere is dense, but its winds at the surface were thought to be generally calm. The potential for waves suggests that Triton might experience weather events, sudden gusts or storms that are capable of churning its strange seas. This introduces a dynamic we rarely consider on other worlds, a form of weather-driven erosion and transport that shapes an alien shoreline. The lakes themselves are not permanent. Some appear to evaporate entirely, leaving behind empty, depression-shaped basins ringed by what might be evaporite deposits, the Triton equivalent of a dried-up salt flat. This whole system, from cloud to rain to river to sea and back to cloud, is a complex chemical engine. The methane is constantly being broken down by sunlight in the upper atmosphere, creating a cascade of more complex organic molecules that rain down on the surface. This means Triton is not just a frozen museum. It is a factory actively producing the very chemical building blocks that, on the early Earth, eventually led to life. What strange chemistry is simmering in those dark, cold lakes, on a world where the familiar rhythm of rain falls not as water, but as liquid natural gas? While Triton's chemistry simmers in cold lakes, another of Saturn's moons performs a far more spectacular display. Enceladus, a small, icy world no larger than the British Isles, is violently alive. From its south pole, colossal geysers blast into space, creating a towering plume of water vapor and tiny ice grains that stretches hundreds of kilometers above the surface. This is not a slow ooze, but a ferocious, continuous eruption, a fountain of material being jettisoned directly from a hidden, global ocean buried deep beneath the moon's frozen crust. The Cassini spacecraft did not just see these plumes, it flew right through them, tasting their composition. What it found was nothing short of revolutionary. The icy particles were not just pure water, they were laced with a cocktail of simple organic compounds, the carbon-based building blocks essential for life as we know it. More astonishing still, the sensors detected a telltale signature of molecular hydrogen and tiny particles of silica, minerals that on Earth are typically formed when hot water interacts with rock on the ocean floor. This single piece of evidence paints a stunning picture. Enceladus is not just a frozen ball with a pocket of water. It possesses a warm, salty, global ocean, its floor a rugged landscape of hydrothermal vents where superheated, mineral-rich water spews into the dark. On our own planet, such sunless, deep sea vents are teeming with life, entire ecosystems that draw their energy not from the sun, but from the chemistry of the Earth itself. The discovery on Enceladus suggests that all the necessary ingredients for life, liquid water, a source of chemical energy, and the right organic compounds are present and mixing in its hidden sea. This tiny, gleaming moon has forcefully inserted itself into the very short list of the most promising places to search for life beyond Earth. The question is no longer if other worlds can host oceans, but what might be stirring in the eternal night of an alien abyss, powered by the quiet heat of a distant moon's core. Uranus presents a moon that seems to defy the very laws of geology. Orbiting this ice giant is Miranda, a world that looks less like a coherent celestial body and more like a collection of mismatched parts. Its surface is a chaotic patchwork of ancient, cratered terrain, immense fault canyons, and bizarre, ridged features called coronae. One of these canyons, Verona Rupes, is a staggering cliff face estimated to be 20 kilometers deep, making it the tallest known cliff in the solar system. If you were to drop a rock from the top, it would take nearly 10 minutes to hear it hit the bottom, but it is the coronae that truly baffles scientists. These are vast, oval-shaped regions covered in parallel ridges and grooves, crisscrossing each other in complex patterns. They look as if the moon's crust was stretched, cracked, and then filled in with new material from below. The overall impression is of a world that was violently shattered into pieces and then hastily reassembled by a cosmic force with no regard for the original design. So how does a moon end up looking so utterly broken? The leading theory is as dramatic as the landscape itself. Scientists propose that in the distant past, Miranda was struck a catastrophic, glancing blow by another large object. The impact was so powerful it likely shattered the Moon completely, fragmenting it into a temporary ring of debris around Uranus. Over time, gravity pulled these pieces back together, a process called reaccretion. But the reassembly was not neat or orderly. Different chunks with different compositions and histories clumped together haphazardly, creating the jumbled patchwork surface we see today. The coronae might be the scars of this reassembly, places where warmer, softer material from the Moon's interior welled up between the larger, colder fragments, freezing into those distinctive ridged patterns. This violent history makes Miranda a unique relic. It is a testament to the sheer destructive power present in the early solar system, and a demonstration of nature's clumsy, persistent ability to rebuild. What other secrets are locked within the fractured ice of this reassembled world, a silent monument to a forgotten collision? Our journey from the shattered moon Miranda brings us directly to its parent planet, a world whose very posture in space is an act of defiance. Uranus does not spin like the other planets it rolls. The planet is tilted over on its side at a 98-degree angle, meaning its axis of rotation is almost parallel to the plane of its orbit around the Sun. Picture a toy top spinning perfectly upright, and then imagine another that has been knocked over and is rolling in a circle on its rim. That rolling top is Uranus, performing a slow, cosmic somersault as it journeys around our star. This extreme tilt is the most pronounced of any planet in our system, and it leads to seasons of almost unimaginable length and intensity. For a quarter of its 84-year orbit, a single pole points directly toward the Sun. This means one hemisphere experiences 42 straight years of relentless daylight, a summer that lasts for generations. Meanwhile, the other hemisphere is plunged into a deep, frigid winter of total darkness for those same 42 years. Only during the brief periods when the Sun is over its equator does Uranus experience anything close to a normal day-night cycle. What colossal force could have knocked an entire planet onto its side? The most compelling theory points to a violent birth. Scientists believe that in the chaotic early solar system, a young Uranus was struck a glancing blow by a protoplanet roughly the size of Earth. This was not a small impact, it was a world-shattering collision, a hit so profound it likely vaporized the impactor and sent Uranus reeling. The planet's spin was permanently altered, leaving it with this bizarre axial tilt we observe today. This single, ancient cataclysm set the stage for everything that followed, creating a world of extreme and prolonged seasons that operate on a timescale far beyond human experience. What strange weather patterns could possibly evolve under a sun that never sets for half a lifetime and then vanishes completely for the next? While Uranus was knocked on its side by a single ancient blow, its blue twin Neptune endures a more constant and turbulent violence. Voyager 2, as it flew past in 1989, captured a storm so immense it could have swallowed our entire planet. They called it the Great Dark Spot, a vast, whirling vortex of deep blue in Neptune's frigid atmosphere, a hurricane of unimaginable scale with winds screaming at over 1,200 miles per hour. Yet, when the Hubble Space Telescope turned its gaze to Neptune just a few years later, the spot was gone. It had simply vanished without a trace. This was not a storm that slowly weakened and dissipated. It was a feature the size of Earth that disappeared from the face of a world in what amounts to a cosmic blink of an eye. This fleeting nature is the defining characteristic of Neptune's dark spots, setting them apart from the solar system's other famous storm, Jupiter's Great Red Spot. That Jovian giant has been raging for at least 400 years, a permanent fixture in its cloud tops. Neptune's storms, by contrast, are like ghosts appearing and vanishing within just a few Earth years. So what makes them so transient? The answer lies in the fundamental nature of the storms themselves. Jupiter's Great Red Spot is a high-pressure anticyclone, a massive, rotating column of rising air. Neptune's dark spots are also anticyclones, but they behave differently in the planet's incredibly dynamic and chaotic atmosphere. Think of Jupiter's atmosphere as a relatively stable, deep ocean where a great whirlpool can spin for centuries. Neptune's atmosphere, however, is more like a shallow, fast-moving river filled with violent rapids and unpredictable currents. This world has the fastest winds in the solar system, driven by internal heat left over from its formation. This creates an environment of immense shear forces, where different layers of the atmosphere are constantly tearing past one another. A dark spot, a high-pressure system trying to spin in one direction, is perpetually being ripped apart by these screaming winds and turbulent eddies. It is a battle between order and chaos, and on Neptune, chaos almost always wins. The storm forms when a massive bubble of high-pressure gas wells up from the deep interior, but it cannot maintain its structure for long against the planet's relentless atmospheric shredding. It is torn to pieces, its dark clouds dispersed and mixed back into the blue hydrogen and methane haze. The Great Dark Spot was not a permanent landmark, but a momentary upheaval, a brief scream of weather in an atmosphere that is forever screaming. This constant churn reveals a world of profound and restless energy, a place where even the largest features are mere temporary sculptures in the clouds, here one moment and gone the next. What does it say about the hidden heart of a planet where Earth-sized landmarks can be created and erased within a single human lifetime? Neptune's own cosmic rebellion orbits just overhead. Its largest moon, Triton, moves in absolute defiance, circling the planet backwards. Every other major moon in the solar system spins in the same direction as its planet rotates, a harmonious family born from the same primordial disk of gas and dust. Triton alone breaks this rule, traveling a retrograde path that marks it as a stranger, an intruder from the dark. This backward orbit is the single greatest clue that Triton was not born alongside Neptune. It is a captured world, a king from the distant Kuiper Belt that was gravitationally kidnapped and forced into service. The event that led to its capture must have been one of the most violent episodes in our solar system's recent history. Imagine the scene. A dwarf planet, larger and colder than Pluto, is sailing through the void on its own independent orbit. Its path brings it too close to the immense gravity of Neptune. In a single, wrenching encounter, the entire course of its existence is shattered. It is likely that Triton was once part of a binary system, two objects orbiting each other. As this pair swung past Neptune, the planet's gravity acted like a cosmic fisherman, catching one of the two and flinging the other away into interstellar space. Triton was the one that was caught, but this capture was not a gentle netting. It was a cataclysm. As Triton was pulled into its new, tight orbit around Neptune, immense tidal forces began to work on the captured world. The constant, changing gravitational pull from the giant planet would have squeezed and stretched Triton's interior, generating immense friction and heat. This tidal heating was so intense that it likely melted Triton completely, turning a frozen, ancient relic into a roiling, molten sphere. Its original surface, possibly cratered and ancient, was utterly erased, submerged beneath a global ocean of liquid rock and ice. As the moon slowly settled into its new, circular orbit over eons, it cooled from the outside in, giving itself a brand new face. This explains its incredibly young surface, one of the youngest in the entire solar system, with few impact craters to mark its age. This violent rebirth also unlocked a strange and ongoing activity. Today, Triton is one of the few known icy worlds with active geysers. Voyager 2 observed dark, dusty plumes rising several kilometers into its thin atmosphere. These are not cryovolcanoes like on Enceladus, but something even more exotic. They are nitrogen geysers. Triton's surface is so cold that much of its thin atmosphere freezes solid during its long winter, falling as nitrogen snow. When the weak sunlight of its summer returns, it shines through this transparent layer of nitrogen ice, acting like a greenhouse. The sunlight heats the dark, dusty material trapped just beneath the ice, warming it enough to vaporize a pocket of frozen nitrogen below. The pressure builds until the nitrogen gas erupts, punching through the icy crust and carrying dark dust high into the sky. This creates a stunning cycle of freezing and eruption, a geological heartbeat driven by the sun. The capture of Triton fundamentally reshaped the Neptune system. Astronomers believe its arrival wreaked havoc on any original moons Neptune possessed, either sending them crashing into the planet or flinging them out into the void. The moons we see today are almost certainly a second generation, survivors of that cosmic upheaval. So we are left with a profound thought. The largest, most dominant moon of Neptune is a permanent reminder of the lawless chaos that built our solar system, a world that was stolen, melted, and reborn, and now vents its nitrogen heart into the perpetual cold. The same gravitational forces that can shatter a moon also perform acts of exquisite cosmic construction. Orbiting within the very heart of Saturn's rings, tiny worlds no larger than cities perform a delicate gravitational ballet. These are the shepherding moons, and their silent, persistent work is what carves and maintains the razor-sharp edges of the rings, transforming what could be a featureless disk into a structure of stunning clarity and precision. Think of a single, narrow ring, a band of countless ice particles all orbiting the planet. If left alone, this band would naturally spread out over time, its inner edge drifting inward and its outer edge drifting outward, becoming a diffuse, blurry smear. But place a small moon in a carefully balanced orbit just outside that band. As this moon, like Prometheus, travels around Saturn, its gravity tugs on the ring particles nearest to it. Each time a particle on the outer edge of the ring tries to drift away, the moon's gravity gives it a slight pull forward, a gentle kick that boosts its energy and pushes it back into a slightly higher orbit, herding it back toward the flock. The result is a perfectly defined outer boundary, as if an invisible fence contains the entire ring. Now, imagine a second moon orbiting just inside the ring. This inner shepherd, like Pandora, does the opposite. Its gravitational pull acts as a brake, stealing energy from any particle that tries to wander outward from the inner edge, causing it to fall back into a lower orbit. Together, these two moons act like celestial sheepdogs, one running ahead of the flock and one behind, confining the countless particles between them into a narrow, well-defined lane. This same principle carves out the stunning gaps within the rings themselves. The most famous of these is the Cassini division, a vast, dark band that looks like it was sliced cleanly through the rings with a cosmic knife. This gap is not empty, it is the domain of a different kind of shepherd. The moon Mimas, orbiting farther out, has a gravitational relationship with the ring particles that creates a resonant clean-up. Particles that fall into specific orbital paths around Saturn, where their period is a simple fraction of Mimas's orbit, feel a repeated, rhythmic tug from the moon. Think of pushing a child on a swing, giving a small push at just the right moment in its arc to make it go higher and higher. Mimas does the same thing with gravitational energy. It gives these particles a consistent series of tiny kicks that gradually add up, altering their orbits enough to eject them from the gap entirely, sweeping the region clean. The dance becomes even more intricate and beautiful with moons like Pan and Daphne's, which orbit directly within the gaps they maintain. As these tiny worlds travel, their gravity doesn't just push particles away, it also sculpts the edges of the gap, pulling and kneading the ring material into undulating waves. In some cases, this creates a rippled, corrugated pattern along the gap's edge. In the case of Daphne's, its slight orbital tilt causes it to bob up and down through the ring plane, carving a sinusoidal wave in the ring material that trails behind it like a wake in water. The most astonishing display is the braided, kinked, and looped patterns created by the gravitational interplay between Prometheus and the thin F-ring. This moon does not maintain a steady distance. Its orbit is slightly elliptical, bringing it diving in towards the ring and then pulling away again. each time it makes a close approach, its gravity drags a stream of material from the ring, pulling it into long, bright tendrils, loops, and braids that look like strands of celestial DNA. These features are temporary, dissolving away before the moon's next pass creates a new, equally complex pattern. This constant, dynamic interaction reveals the rings not as a static, frozen photograph, but as a living, breathing system, a fluid canvas upon which gravity paints with an artist's touch. How many other subtle, beautiful dances are happening right now in the quiet dark, choreographed by the simple, universal law of gravity? Gravity's subtle signature extends far beyond the rings of Saturn, written in the lonely paths of distant ice worlds. Out in the frigid darkness of the Kuiper Belt, beyond the orbit of Neptune, a population of small, frozen bodies follows their own slow tracks around the Sun. But a handful of these extreme Kuiper Belt objects do not move at random. Their highly elliptical orbits are mysteriously clustered, as if an unseen hand has gathered them together, aligning their closest approaches to the Sun in a way that defies easy explanation. This peculiar orbital alignment is the solar system's most tantalizing gravitational clue. When astronomers calculated the forces at play, they found that the combined gravity of the known planets could not produce this specific clustered pattern. The orbits of these distant objects seem to be shepherded, their paths twisted into alignment by the persistent, gentle tug of something massive lurking in the perpetual twilight. The most compelling explanation for this celestial herding is a hypothetical world we call Planet 9. This would not be a small, rocky body, but a true giant, a potential super-Earth or mini-Neptune with a mass up to 10 times that of our own world. Its orbit would be vast and highly inclined, swinging hundreds of times farther from the Sun than Earth, taking perhaps 15,000 years to complete a single, slow journey around our star. Finding such a world is the astronomical challenge of a lifetime. Its incredible distance means it reflects virtually no sunlight back to our telescopes, making it 1 billion times fainter than Pluto. Its motion across the sky would be agonizingly slow, a barely perceptible crawl against the backdrop of fixed stars. The search is a meticulous process of comparing vast, deep sky images taken months or years apart, looking for that one tiny speck of light that has shifted its position. Yet the indirect evidence remains powerful. How else can we explain why these distant Kuiper Belt objects are perpetually swung away from a certain region of the sky, their orbits pushed to extremes by a gravitational presence we cannot yet see? The hunt for Planet 9 is a profound reminder that the maps of our own solar system are still unfinished, that a true giant could still be hiding in the vast, uncharted territories at the very edge of our Sun's influence. What other fundamental truths about our cosmic neighborhood are waiting to be discovered, not by looking at what we can see, but by deciphering the silent whispers of gravity itself? Jupiter's atmosphere is a canvas of constant, violent creation, while the Great Red Spot commands attention as an ancient, enduring storm. Another powerful vortex has emerged right beside it. This is Oval Ba, a tempest born from the merger of 3 smaller, white ovals observed throughout the 20th century. When these storms finally coalesced in the year 2000, they created a single, powerful system that soon underwent a startling transformation. Its creamy white clouds began to deepen into a reddish hue, earning it the popular nickname Red Spot Jr. Here was a new giant storm, not centuries old, but a modern offspring of Jupiter's turbulent weather. What does the sudden coloring of this storm tell us? The leading theory points to the storm's intensification. As Oval Ba grew stronger, its swirling winds began to act like a colossal elevator, dredging up deeper material from the lower atmosphere. Scientists suspect that this material contains certain compounds, perhaps complex hydrocarbons or phosphorus, that are normally hidden far below the visible cloud tops. When these substances are lifted high into the upper atmosphere, they are exposed to the Sun's powerful ultraviolet light. This solar radiation acts like a catalyst, triggering a chemical reaction that darkens the compounds, staining the storm clouds with that distinctive brick red color. This process mirrors what we believe happens in its massive neighbor, suggesting that a storm's color is a direct indicator of its power and depth. The two spots, however, are far from identical twins. The Great Red Spot is an immense anticyclone, a high-pressure system that has been spinning for over 400 years. It is a vast, cold, and incredibly stable feature, rooted deep in the planet's fluid interior. Red Spot Jr. is also an anticyclone, but it is younger, warmer, and behaves more erratically. It has been observed changing color, fading from red back to a less intense white, and then reddening again. It has also shrunk and grown, and even bounced off its famous parent storm when their paths brought them too close. This dynamic interaction reveals a key difference in their life cycles. The Great Red Spot is a seasoned veteran, slowly shrinking but still holding its own against the planet's chaos. Oval Ba is a vibrant adolescent, still figuring out its place in the atmosphere, its fluctuations giving us a real-time look at how these giant storms are born, mature, and potentially die. Observing them side by side is like watching weather history unfold from a stable, ancient system to a younger, more volatile one. Their dance offers a unique laboratory for understanding the forces that can sustain a storm for centuries or see it fade away in just a few decades. What other giants might be brewing in those multicolored cloud bands, waiting for their moment to rise and turn red? While the great storms of Jupiter rage overhead, one of its moons may be offering us a direct taste of its deepest secret. The Hubble Space Telescope has observed what appear to be fleeting, towering plumes of water vapor erupting from the icy crust of Europa. These are not constant fountains like those on Enceladus, but sporadic, elusive events where water vapor may shoot nearly 100 miles above the surface before freezing and falling back as a faint snow. Their intermittent nature makes them maddeningly difficult to confirm, yet the potential implications are staggering. These plumes are our potential key, a direct sample of the global, salty ocean hidden beneath Europa's frozen shell. This moon's ocean is not a small, isolated pocket. It is a vast body of liquid water containing more than twice the volume of all the oceans on Earth combined, sealed under an ice crust many miles thick. To drill through that ice to reach the water below is a feat of engineering far beyond our current capabilities. But if these plumes are real, they are doing the work for us, carrying tiny droplets of that hidden sea up into the vacuum of space. Imagine a future spacecraft not needing to land or drill, but simply flying through one of these faint cosmic geysers. Its instruments could analyze the composition of the water, tasting for salts, organic molecules, and complex chemicals. It would be like taking a blood sample from the moon, diagnosing the health and potential of its hidden ocean. The discovery of even simple organic compounds in those particles would fundamentally transform Europa from a promising candidate into the primary target in our search for life elsewhere. What strange chemistry is brewing in that sunless subsurface abyss, and is it being gently exhaled into space, waiting for us to simply reach out and catch it? Pluto is not alone in its dance through the frozen dark. It shares its orbit with a partner so large that it redefines the very idea of a moon. Charon is not a small satellite, it is a world in its own right, with a diameter just over half that of Pluto itself. This size ratio is unlike anything else in our solar system. Our own moon is a mere sliver of Earth's mass, a clear attendant to its planetary host, but Pluto and Charon are different. Their gravitational relationship is a conversation between near equals. The point they both swing around, the barycenter, does not lie deep within Pluto. Instead, it hangs in the empty space between them, a silent pivot for their mutual orbit. This makes them the solar system's only confirmed binary planetoid system, a double world locked in an endless, intimate waltz. This shared center of gravity has profound consequences for how they move. both worlds are tidally locked to one another. This means the same sides of Pluto and Charon perpetually face each other, a cosmic embrace frozen in time. If you were standing on the surface of Pluto, Charon would hang motionless in your sky, a gigantic grey companion that never rises and never sets. It would dominate the heavens, its craters and plains eternally fixed in your view. From the other side of Pluto, you would never see Charon at all, its presence only a ghostly pull on your world. The same is true in reverse. A Charon resident would see a forever fixed Pluto looming overhead. This perfect locking is the result of eons of gravitational friction, a gentle but persistent tug of war that has slowly braked their spins until they achieved this synchronized state. What would it be like to live on a world where your sky is dominated by a single permanent landmark, a silent partner in your journey around the sun? This binary relationship suggests a shared, violent origin. The prevailing theory is that a colossal impact early in the solar system's history shattered a young Pluto, with much of the debris coalescing to form Charon from the remain. Their current dance is the peaceful echo of that ancient cataclysm, a reminder that even in the coldest reaches of space, worlds are rarely born in isolation. Even a planet's sense of direction can be lost over billions of years. Mars holds a geological record of a profound identity crisis, evidence that its very north and south poles have wandered across its surface. This is not the slow, predictable wobble of Earth's axis, but a dramatic reorientation of the entire planet, a phenomenon called true polar wander. Imagine a spinning top perfectly balanced, its axis straight. Now glue a heavy lump of clay to one side and watch what happens. The top's spin becomes wobbly, and its axis of rotation shifts to accommodate the new weight. Mars experienced this on a planetary scale. The colossal Tharsis bulge, a vast volcanic plateau the size of a continent, is that lump of clay. This region, home to the largest volcanoes in the solar system, including Olympus Mons, formed from an immense upwelling of molten rock over eons. The sheer mass of all that solidified lava piled high in one spot created a profound imbalance. To regain stability, the entire rigid outer shell of the planet shifted, sliding over its inner mantle. The geographic poles, the points that define the axis of spin, physically migrated to new locations. What was once the equatorial region became the new polar zone, and former polar landscapes were dragged into temperate climes. How can we possibly know this happened? The proof is written in the fossilized magnetic fields locked within the ancient southern highlands. Early Mars had a global magnetic field, and as its surface rocks cooled, they captured a magnetic signature, a snapshot of the field's direction at that time. By mapping these magnetic stripes, scientists found that their alignment does not point to the current poles, but to a completely different set of ancient poles. The planet's crust has literally moved, carrying these magnetic fossils with it. This grand reorientation explains other Martian mysteries, like why enormous, deep canyons and river valleys are found in regions that should have been frigid and dry in their past locations. Perhaps they were carved by water when those areas sat at the much warmer mid-latitudes before the great shift dragged them into the cold. This wandering of the poles reveals a planet with a dynamic and tumultuous interior, a world whose very face was remade by the violence of its own volcanic heart. What other ancient landscapes are waiting to be understood, not as they appear today, but as they were when the planet spun on a different axis? These brilliant gashes look like cosmic claw marks scraped across the moon's icy face. On Saturn's moon Dione, vast networks of bright, linear streaks slash across the ancient, cratered terrain, features so striking they have been nicknamed the cat scratches. They are not canyons or deep ravines, but rather luminous lines painted onto the surface, some stretching for hundreds of kilometers in remarkably straight paths. Their dazzling brightness is the key clue, suggesting they are made of a material far newer and cleaner than the dark, dusty ice surrounding them. It is as if a giant hand took a chisel of pure ice and scored these deep grooves into the moon, exposing a brilliant interior that has not yet been darkened by the constant rain of space dust. So what geological force could possibly create such pristine, linear features on a world we thought was geologically silent? One compelling theory points to tectonic forces slowly tearing Dione apart. The moon could be subjected to global stresses, perhaps from the gravitational tug of war with Saturn, causing its brittle icy crust to crack and fracture. These bright streaks would then be the exposed walls of brand new faults, where freshwater ice from below has been revealed, not yet weathered by the harsh space environment. Another, more dynamic idea proposes that these are not just cracks, but the sites of ancient eruptions. The bright material might be a volatile substance like ammonia, ice, or other exotic frozen gases that once oozed up from Dione's warmer interior through long, straight fissures. This material would have coated the surface in brilliant, reflective sheets, creating these stark lines against the older landscape. A third, more subtle hypothesis suggests a process called mass wasting, where material simply slides downslope. Perhaps a small impact or a moonquake caused a section of a cliff face made of bright, subsurface ice to collapse, sending a cascade of clean ice dust streaming down across the darker plains, painting a temporary bright streak that we see as a scratch. Each of these ideas has its own merits, yet each also faces difficult questions. If they are tectonic fractures, why are they so brilliantly reflective and not darkened over time? If they are cryovolcanic deposits, why is there no obvious buildup of material, no raised ridges or volcanic plains? And if they are simple landslides, how do they maintain such impossibly long, straight, and parallel lines across vast distances? The cat scratches of Dione remain a beautifully preserved enigma, a stark reminder that even a seemingly inert moon can hold onto profound secrets, its surface a cryptic diary of internal stresses and ancient upheavals we are only just beginning to read. Deep within the swirling atmospheres of Jupiter and Saturn, a strange precipitation falls. This is not a rain of water or methane, but a storm of liquid helium, a phenomenon born from physics so extreme it reshapes our understanding of these giant worlds. To comprehend this, we must journey into the heart of a gas giant, where the very nature of matter is transformed. The outer layers are a tempest of molecular hydrogen, but as we descend, the pressure builds to millions of times greater than the air pressure at Earth's surface. Here, something remarkable happens. The incredible force squeezes the hydrogen atoms so tightly that their electrons are knocked loose, creating a vast, seething ocean of electrically conductive fluid known as metallic hydrogen. It is a form of hydrogen that behaves like a liquid metal, and its creation marks a fundamental shift in the planetary interior. Within this bizarre metallic sea, another element is dissolved, helium. But under these new, extreme conditions, helium becomes an outsider. It cannot mix easily with the metallic hydrogen, much like oil separates from water. The helium becomes insoluble, forcing it to condense into droplets. These droplets, heavier than the surrounding metallic hydrogen fluid, begin to fall. A silent, perpetual rain of liquid helium descends deeper into the planet's core. This is not a gentle shower, but a global deluge of immense energy. As the helium droplets sink through the metallic hydrogen, friction and gravitational energy are released in the form of heat. This process acts like a hidden furnace, generating an enormous amount of extra warmth within the planet. For Saturn, this explains a long-standing mystery. The planet radiates nearly 2.5 times more heat than it receives from the Sun, and helium rain is a primary suspect for this excess energy. This internal rainfall also has profound consequences for the planet's composition and evolution. As the helium drains from the upper layers, it depletes the atmosphere of this element, which matches observational data. Meanwhile, the raining helium enriches the deeper interior, potentially settling into a distinct layer around the core. This continuous process changes the planet's internal structure over billions of years, influencing its magnetic field and its very longevity. The gentle patter of this exotic rain, happening on a scale we can barely imagine, is a fundamental driver of planetary life. It is a beautiful reminder that the true engines of these colossal worlds are not just their turbulent surfaces, but the silent, alchemical storms raging deep within their hidden hearts. The silent, falling rain within a gas giant is a hidden process, but some cosmic visitors announce their strangeness with brilliant and unmistakable flares. In 2017, our solar system received its first known tourist from interstellar space, an object hurtling through on a one-way journey from the galactic void. Astronomers named it Oumuamua, Hawaiian for scout or messenger from the distant past. Its arrival was an event of profound significance, a rock from another star. But it was the way this scout behaved that ignited a firestorm of scientific debate and public wonder. The first clue to its bizarre nature came from its light curve, the pattern of its brightness as it tumbled through space. The object's brightness varied dramatically by a factor of 10 in a regular cycle lasting about 8 hours. This could only mean one thing: Oumuamua was not a roughly spherical body like most asteroids and comets. It was profoundly elongated, shaped like a pancake or perhaps a cigar, with dimensions estimated at perhaps 10 times longer than it was wide. This was an object with a geometry rarely, if ever, seen in our own solar system. Then came the second and greater mystery. As astronomers tracked its path, they found it was not following a purely gravitational trajectory. Something was giving it an extra push, a tiny but persistent non-gravitational acceleration that gently altered its course as it sped away from the Sun. This is a behavior commonly seen in comets, where the Sun's heat vaporizes ices on the surface, creating jets of gas that act like natural rocket engines. The crucial difference was that Oumuamua showed no visible signs of this activity. It had no glowing coma, the fuzzy envelope of gas and dust that surrounds a comet's nucleus, and no detectable tail streaming behind it. It looked like an inert, rocky asteroid, but it was accelerating like an active comet. So what invisible force was propelling it? The scientific community scrambled for answers. The leading natural explanation involves a process called outgassing. Perhaps Oumuamua was a comet after all, but one made primarily of molecular hydrogen ice. When warmed by the Sun, solid hydrogen could sublimate directly into a gas, creating the necessary jet thrust. The beauty of this theory is that hydrogen gas is invisible to our telescopes, which would perfectly explain the lack of a visible coma. The object would be venting an undetectable propellant. However, this idea faces its own challenges, as molecular hydrogen ice is very fragile and would struggle to survive a long journey through interstellar space. The puzzling combination of facts, the strange shape, the mysterious acceleration, and the complete lack of visible debris, inevitably led to more speculative ideas. Some scientists wondered aloud if we were looking at a piece of alien technology, perhaps a light sail, a vast, thin sheet designed to be pushed by the radiation pressure from starlight. This would account for both its flat shape and its non-gravitational motion. While this remains a fringe hypothesis, its very proposal highlights just how unusual this object was, forcing us to confront the limits of our current understanding. Oumuamua was a messenger, all right. It delivered a clear and humbling message that the universe is capable of crafting objects that defy our standard categories, and that our first contact with another star system was with something we still cannot fully explain. What other strange travelers are drifting between the stars, carrying the untold stories of distant suns? The surface of Mars's moon Phobos is etched with a haunting pattern of deep, parallel grooves, as if a giant comb has been dragged across its face. These long, straight lines stretch for kilometers, cutting across craters and valleys in a uniform, almost mechanical pattern. This tiny, lumpy moon, barely 27 kilometers across at its widest point, is covered in these mysterious scars. For decades, astronomers debated what could carve such precise features into a world so small. The answer may lie not in its past, but in its terrifying future. The leading theory connects these grooves directly to the gravitational pull of Mars. Phobos orbits incredibly close to its planet, so close that it completes a full revolution in just 7 hours and 39 minutes. Mars exerts a powerful tidal force on its small companion, a relentless gravitational tug that is slowly, inexorably pulling the moon apart. Think of Phobos as a ball of loosely packed rubble held together by its own meager gravity. As it circles Mars, the planet's gravity stretches it slightly. This constant flexing creates immense stress within the moon's core, causing the entire body to fracture along lines of weakness. The parallel grooves we see are likely the surface expression of these deep-seated stress fractures, the first cracks in a celestial body destined for a spectacular demise. In perhaps as little as 40 million years, these cracks will widen until Phobos is completely torn asunder, its debris likely forming a temporary ring around the red planet. The grooves, then, are the death marks of a doomed world, a preview of its final act written across its surface for all to see. Yet a compelling alternative theory suggests a different, though equally violent, origin. Some scientists point to the massive Stickney crater, a colossal impact scar that dominates one end of Phobos. The energy from that ancient, shattering blow would have sent seismic waves rippling through the small moon, shaking its entire structure. This alternative idea proposes that the grooves are not internal cracks, but chains of secondary crater pits. When a large object strikes a surface, it can blast material out in long, linear streams. This ejected debris then falls back down, creating lines of smaller craters or pit chains that radiate from the primary impact. From a distance, these aligned pits can look like continuous grooves. This theory elegantly links the grooves to a single, catastrophic event in Phobos' history. The debate between these two ideas, a slow death by tidal stress or a violent past marked by a single impact, continues. Perhaps the truth is a combination of both, where the ancient impact weakened the moon, making it more susceptible to the tidal forces that now fracture it. Either way, the grooves of Phobos tell a story of a fragile world living on borrowed time, its surface a permanent record of the immense forces that govern its existence. Far from the fractured surface of Phobos, another small world reveals a strange and brilliant glow. The dwarf planet Ceres, the largest object in the asteroid belt, is home to one of the solar system's most captivating puzzles, the dazzling bright spots of Ocata crater. From a distance, these spots look like a collection of celestial lanterns shining from the crater floor, but close-up views from the Dawn spacecraft revealed their true nature. They are vast deposits of gleaming white salt, primarily sodium carbonate, a substance you might recognize as washing soda or a key ingredient in certain types of glass. Finding such a concentrated deposit on the surface of an airless, rocky world was completely unexpected. Sodium carbonate on Earth is typically associated with hydrothermal activity, formed when hot, mineral-rich water interacts with rock and then evaporates, leaving the salts behind. Its presence on Ceres was a direct clue that this small world was not the dead, static rock we once assumed. The leading explanation for these brilliant features is as elegant as it is surprising. Scientists call it the brine reservoir model. Imagine a vast, muddy layer of salt water, a subsurface aquifer, sloshing deep beneath the crater's surface. This reservoir is not a calm, placid lake, but a thick, icy slush loaded with dissolved salts and other minerals. Millions of years ago, the impact that created Ocata crater itself fractured the crust, creating a network of deep cracks and faults that reached all the way down to this hidden brine layer. This was like punching a hole in a pressurized container. Suddenly, a pathway was open. The muddy, salty brine began a slow, persistent ascent, seeping up through the fractures toward the much colder surface. As this mineral-rich slurry approached the vacuum of space, it underwent a dramatic transformation. The water component instantly flash-froze, creating a hard, icy crust, while the dissolved salts within it crystallized out, forming the brilliant, reflective deposits we see as the bright spots. This process did not happen just once. The Dawn spacecraft found evidence that the central, brightest area, called Cerealia Facula, is geologically very young, perhaps only a few million years old. This suggests that the upwelling of brine was not a single event following the impact, but an ongoing, intermittent process. The dwarf planet may still possess just enough internal warmth, perhaps from the decay of radioactive elements, to keep its subsurface brines liquid and slowly churning. This makes Ceres a fascinating hybrid, a world with the icy, volatile-driven geology of a distant moon, but located in the relative warmth of the inner solar system. The bright spots are not ancient relics, but the frozen breath of a world that is still subtly active, its internal chemistry slowly bubbling up to paint its surface with temporary, shining art. What other hidden oceans might be stirring beneath the dark, rocky surfaces of the asteroid belt, their existence betrayed only by a sudden, brilliant gleam in the sunlight? Uranus conceals a magnetic personality far stranger than its sideways spin. When Voyager 2 swept past the ice giant, its instruments detected a magnetic field unlike any other in our solar system, a chaotic and lopsided force field that seems to stagger around the planet. For a typical world like Earth, the magnetic field is a relatively orderly affair. It is generated by the churning of molten iron in the outer core, creating a magnetic axis that is roughly aligned with the planet's axis of rotation. Our north and south magnetic poles are close to the geographic poles, which is why a compass points north, but Uranus plays by a different set of rules. Its magnetic field is not centered on the planet's core. Instead, the source of this immense magnetic bubble is offset, shifted by nearly a third of the planet's radius. To visualize this, imagine a simple bar magnet at the heart of a sphere. On Earth, that magnet is centered, pointing nearly straight up and down. On Uranus, that magnet is shoved off to one side, and it is also tilted at a drastic 59-degree angle from the planet's rotational axis. This means the magnetic poles are nowhere near the geographic poles. If you tried to use a compass on Uranus, it would point to a spot in empty space, far from the axis around which the planet actually spins. This bizarre configuration creates a magnetic field that does not simply rotate, it tumbles. As the planet rolls along its orbit, its lopsided and tilted magnetic field wobbles and precesses violently. The solar wind, that constant stream of particles from the sun, does not hit a stable magnetic shield. It strikes a twisting, asymmetrical barrier that is different with every rotation, a cosmic tumbleweed of magnetic force. What could cause such an irregular field? The answer is likely buried deep within the planet's unique interior. Scientists believe that within Uranus, the pressures are too great for a molten iron core to exist in the same way it does on Earth. Instead, the magnetic field is probably generated in a vast, superheated ocean of water, ammonia, and methane. Under the incredible pressure, these compounds break down into ions, creating an electrically conductive fluid sometimes called a water-ammonia ocean. This is not a place for life, but a seething, high-pressure soup where complex chemistry generates magnetic fields. Because this conductive layer is relatively close to the surface and likely has a more uneven, churning motion than a deep iron core, it produces a magnetic field that is messy, off-center, and wildly tilted. This strange magnetic field is more than just a curiosity. It has dramatic consequences for the planet's environment. The tumbling field creates an aurora that is not a neat ring around the poles, but a chaotic, shifting light show that can appear almost anywhere on the planet. It is a fitting signature for a world that defies every convention, a planet knocked on its side and harboring a magnetic heart that beats to its own erratic rhythm. The strange chemistry of Titan's methane lakes will soon have a visitor. NASA Dragonfly mission is not a rover or a stationary lander. It is a revolutionary robotic rotorcraft, a drone designed to fly through the thick, hazy atmosphere of Saturn's largest moon. This ambitious project will transform Titan from a distant, puzzling world into a hands-on laboratory for prebiotic chemistry. Dragonfly will use its 8 rotors to lift off from the surface, traveling dozens of kilometers at a time to explore dozens of different locations across the alien landscape. It will land on the shores of methane seas, touch down on vast dune fields of organic sand, and settle inside the icy rims of ancient impact craters. At each stop, its suite of instruments will perform a delicate autopsy on the surface, drilling into the ground to sample the water ice and complex organic materials that have been raining down from the atmosphere for billions of years. This is the mission's primary goal, to investigate the same chemical processes that, on the early Earth, eventually led to the emergence of life. Titan is a frozen archive, preserving in deep freeze the kind of chemistry that was present on our own planet before life ever began. By flying from site to site, Dragonfly will be able to piece together how these organic molecules form, how they interact with liquid methane and water ice, and whether they have the potential to assemble into even more complex structures. It will listen for Titan quakes to understand the moon's internal structure and study the atmosphere to learn about its complex weather patterns. This mission turns a bizarre environmental event, a world with rivers of liquid natural gas, into the most promising astrobiology target in our solar system. We are no longer just observing Titan from orbit. We are preparing to fly through its orange skies and taste its strange soil, searching for answers to the most profound question of all. Are we alone in the universe, or is the chemistry of life a common story, waiting to be read on worlds we are only just beginning to understand? Gravity's symphony plays out in perfect time around Jupiter, where 3 of its largest moons are locked in an unbreakable rhythm. Ganymede, Europa, and Io do not orbit at random. Their paths are bound together by a precise gravitational agreement known as orbital resonance. For every single orbit that Ganymede completes, Europa completes exactly 2, and fiery little Io completes 4. This 1:2:4 ratio is not a coincidence, it is the key to their stability. Picture 3 runners on a circular track, each at their own lane. The slowest runner on the outside is Ganymede, the middle runner is Europa, and the fastest on the inside lane is Io. Every time Ganymede completes 1 slow lap, Europa has finished 2 and Io has whipped around 4 times. They keep meeting at the same exact point on the track over and over again. This regular, repeated alignment allows their gravitational fields to give each other a consistent, predictable tug. Instead of pulling each other into chaotic, wandering orbits, these rhythmic tugs reinforce their paths, locking them into this stable, repeating pattern that has likely persisted for billions of years. But this celestial harmony has a violent side effect, and the moon that feels it most intensely is Io. Every time Io catches up to Europa in its faster orbit, and every time the pair together align with Ganymede, the combined gravity of its siblings gives Io a forceful, rhythmic squeeze. Jupiter's immense gravity is already stretching and flexing the small moon, but these regular gravitational kicks from Europa and Ganymede amplify the effect tremendously. This constant internal flexing generates immense tidal friction, heating Io's interior to melting point. The entire moon essentially functions like a piece of metal being bent back and forth until it becomes scorching hot. This is why Io is the most volcanically active body in the entire solar system. Its surface a constantly changing canvas of erupting vents and lakes of molten lava. Its vibrant colors, yellows and oranges and reds, are the direct result of this gravitational bullying. a world literally turned inside out by the perfectly timed pushes and pulls of its neighbors. This resonant system reveals a profound truth about our solar system, that stability and chaos are often two sides of the same coin. The same gravitational agreement that keeps these moons in a steady, predictable dance is also the very force that relentlessly tortures one of them, driving a geological inferno that lights up the Jupiter system. What other delicate balances between order and violence are playing out in the darkness, their rhythms so perfect they become engines of destruction? Even Jupiter's most permanent-looking features are engaged in a slow, cosmic dance. The planet's striped face, a tapestry of creamy white zones and reddish-brown belts, is not a fixed portrait but a living, breathing entity. These cloud bands have been observed for centuries to shift in both color and width, sometimes fading dramatically or darkening with an intensity that can be seen from Earth. The zones, the light-colored bands, are regions of rising gas, where warmer air from the depths billows upward and spreads out, cooling to form bright ammonia ice clouds. The darker belts, by contrast, are areas where the cooler, drier air is sinking back into the planet's interior. This creates a planet-wide atmospheric conveyor belt, with material constantly rising in the zones and sinking in the belts. But why do these sinking regions sometimes transform into such deep, rich hues of orange, red, and brown? The secret lies in the chemistry of the downdraft. As the air plunges downward in the belts, it carries with it certain chemical compounds from the upper atmosphere. Scientists suspect these include complex hydrocarbons, phosphorus, or sulfur-bearing molecules. When these substances are pulled into the deeper, warmer layers of the atmosphere, they are exposed to the sun's intense ultraviolet radiation, which acts like a cosmic artist's brush. The UV light triggers a photochemical reaction, breaking apart and reassembling the molecules into new, more complex compounds that have a darker, reddish color. This is similar to the process that stains the great storms, but it operates on a global, cyclical scale. The entire face of Jupiter is therefore a dynamic chemical laboratory. A belt may lie pale for years, then, as the atmospheric currents shift and the downwelling intensifies, it dredges up more of these precursor chemicals, and the entire band darkens into a pronounced coppery stripe. The widths of these bands also change as the underlying jet streams that define their boundaries fluctuate in speed and power. What appears from a distance as a serene and majestic giant is in truth a world of seething change. Its beautiful stripes a direct readout of the violent, invisible churning deep within its heart. How many other gas giants across the galaxy are painting and repainting their own faces with these same slow, majestic strokes? Ganymede's face is a stark patchwork of ancient darkness and brilliant, youthful light. Vast stretches of this giant moon are covered in strangely smooth, bright terrain, grooved with long, parallel ridges as if a cosmic rake has combed its surface. These regions are conspicuously clean, nearly free of the deep, pockmarked craters that typically record a world's long and violent history. Such smoothness is a profound clue, a sign that something powerful and geologically recent has scrubbed the surface clean, effectively hitting the reset button on Ganymede's appearance. For a landscape to be so devoid of craters, it must have been repaved, the old, scarred surface erased and replaced with something new. But what force could possibly resurface an entire world, especially one so far from the sun's warmth? The answer lies in a hidden ocean. Ganymede is not a simple ball of ice and rock. It possesses a deep, liquid water ocean trapped between layers of ice, a world-spanning sea sealed away beneath a frozen crust. In the moon's turbulent past, this subsurface ocean may have found a way to breach the surface. Imagine a colossal fracture opening in the icy shell, a tectonic wound miles deep. From this fissure, a slow, frigid slurry of water and ice could have erupted, flooding the surrounding landscape. This wasn't a violent, fiery explosion, but a vast, creeping outpouring of slush that spread across thousands of square kilometers. As this watery mix met the vacuum of space, it would have instantly frozen, creating a new, pristine layer of ice, a fresh canvas that buried all the ancient craters beneath it. The distinctive grooved patterns that cover these bright plains are the frozen wrinkles of this resurfacing event, the stress marks from the moon's crust stretching and cracking as it shifted over its liquid interior. This ongoing tectonic activity, likely driven by the gravitational tug of war with Jupiter and its sister moons, continually reworks the surface, smoothing out the past and writing a new geological story. Ganymede's youthful face is therefore a direct window into its warm, wet heart, proving that even in the deep freeze of the outer solar system, worlds can remain geologically alive, constantly remaking themselves from the inside out. Deep in the Kuiper Belt spins a cosmic top unlike any other. Haumea, a dwarf planet, whirls with such dizzying speed that it has been stretched into the shape of a flattened football. This rapid rotation, completing a full spin in less than 4 hours, has sculpted a world of extremes. Its elongated form is only the beginning of the mystery. For such a distant, icy body, Haumea possesses a surprisingly high density. This suggests that beneath a thin, reflective shell of water ice lies a remarkably rocky and massive core. How can a world so far from the Sun, in a region dominated by frozen volatiles, be composed mostly of rock? The plot thickens with the discovery that Haumea is also encircled by a faint but distinct ring system. This is a feature we once thought exclusive to giant planets like Saturn. A fast spin, a rocky interior, and a ring, all wrapped around one small, distant object. The most compelling story that ties these bizarre clues together points to a cataclysm of unimaginable force. Astronomers theorize that in the deep past, a colossal impact shattered a larger proto-Haumea. The violence of this collision was so specific, so glancing, that it set the surviving fragment spinning wildly, ejecting vast amounts of its lighter icy mantle into space and leaving behind the dense, rocky core we infer today. The debris from this ancient crash is thought to have created Haumea's family of smaller, icy moons, and most remarkably, its delicate ring. This ring could be a temporary band of pulverized material or a more stable structure held in place by tiny, unseen shepherd moons. Haumea stands as a frozen monument to a single, shattering moment, a world whose very shape and substance whisper the story of its violent birth. What other reshaped worlds are tumbling in the darkness, their true histories written in their spin and their density? Even the planet's own light shows refuse to follow the rules. The auroras of Uranus are faint, scattered spectacles that shimmer in unpredictable patterns across its atmosphere. Unlike Earth's brilliant northern and southern lights, which dance in neat rings around our magnetic poles, the auroras on Uranus are a chaotic mess. This bizarre behavior is a direct consequence of the planet's two greatest oddities, its extreme tilt and its wildly off-center magnetic field. Here, the magnetic poles are nowhere near the geographic poles. As the planet rolls on its side through its orbit, its lopsided magnetic field tumbles along with it, creating a constantly shifting target for the solar wind. When those charged particles from the Sun slam into this wobbling magnetic shield, they are funneled not toward two fixed points, but along a chaotic, migrating pathway. This means the auroras can flicker to life almost anywhere on the planet, appearing in fragmented patches far from where any earthly observer would expect to find them. They are not the grand, predictable curtains we know, but fleeting, isolated glows that appear and vanish with the planet's erratic rotation. Catching one in the act is an immense challenge for astronomers, requiring precise timing and a good deal of luck. These faint, scattered lights are the perfect signature for such an enigmatic world, a visible manifestation of the profound internal disorder that defines this ice giant. What other secrets are hidden behind these capricious cosmic curtains, their faint glow a testament to a world spinning utterly out of sync with the rest of the solar system? Even the warmth on a frozen world can be a lie. The surface of Enceladus is one of the most reflective places in the solar system, a brilliant ball of ice that should be coldest at its poles where sunlight strikes at the lowest angle. Yet when the Cassini spacecraft mapped its temperatures, it found a stunning reversal of expectations. The warmest spots on this entire moon were not at its sun-bathed equator, but along the 4 deep, parallel fractures known as the tiger stripes, gouged into its south pole. These chasms were radiating significant heat, creating a localized thermal anomaly that defied the simple rules of solar heating. This was not warmth from the sun, but a fever from within. The heat pouring from these cracks was the definitive proof that the colossal plumes of water vapor and ice shooting into space were being powered by a vast, hidden energy source deep inside the moon. The tiger stripes are essentially open wounds in the icy crust, thermal windows offering a direct glimpse into the enormous reservoir of heat contained in the subsurface ocean. This internal warmth is generated by the relentless gravitational squeezing from Saturn. As Enceladus travels along its slightly elliptical orbit, the planet's immense gravity pulls and stretches the moon with a rhythmic tidal force. This constant flexing generates friction deep within its core, heating the rock and keeping the global ocean from freezing solid. That heat has to escape, and it finds its easiest pathway to the surface through these precise fractures at the South Pole. The entire system functions like a natural geothermal plant, where tidal energy is converted into thermal energy, which then violently vents into space, carrying with it samples of the ocean's salty water and organic molecules. This discovery transforms our understanding of habitability. A world does not need to orbit close to a star to be warm. It can generate its own life-sustaining heat from gravitational relationships, turning a small, icy moon into one of the most promising places to search for life beyond Earth. What strange chemistries are being simmered in that dark, warm sea, powered not by a distant sun, but by the persistent, silent flexing of a giant's grip? The bizarre shapes and violent histories of distant dwarf planets are just fragments of a much larger story. Stretching far beyond the orbit of Neptune lies the Kuiper Belt, a cosmic graveyard where the raw materials of our solar system have been kept on ice for more than 4 billion years. This vast, donut-shaped region is not empty space. It is a sprawling reservoir of frozen time, filled with countless icy bodies left over from the very dawn of our planetary system. These are not the polished, finished worlds of the inner solar system. They are the leftover building blocks, the primordial bricks that never coalesced into a planet, preserved in the deep freeze of the outer dark. Each one of these Kuiper Belt objects is a time capsule, a piece of the original protoplanetary disk that swirled around our infant sun. When we study them, we are not just looking at distant rocks, we are conducting the ultimate archaeological dig into our own cosmic origins. Their chemical composition, their strange colors, and the very ice that coats their surfaces are all pristine records of the conditions present when the planets were first beginning to form. Think of our solar system as a finished cathedral. The inner planets are the grand halls and stained glass, complex and transformed by heat and pressure. The Kuiper Belt is the original quarry, the source of the raw stone, where the untouched blocks still lie exactly as they were cut, waiting to tell you how the entire structure was planned. By analyzing the ices on these objects, scientists can determine the temperature of that primordial disk and understand the chemical soup that was available to create worlds like Earth. The different colors observed among these bodies, from dull gray to deep red, hint at a complex history of radiation baking their surfaces, creating a kind of primordial tar that might hold the very organic compounds that seeded life elsewhere. This is why finding a binary system like Pluto and Charon is so significant. It is a frozen snapshot of the collisions and mergers that built all the planets, a process that was completed long ago closer to the sun but remains unfinished out here in the cold. Every lump of ice and rock in this distant belt holds a piece of the puzzle, a silent testimony to the chaotic and violent construction project that eventually led to us. What other fundamental secrets about our own existence are locked away in this frozen archive, orbiting silently in the perpetual twilight? The strange events of the outer solar system are not just puzzles from the past, they are destinations for the future. A new generation of robotic explorers is being prepared to journey into the dark, each designed to answer the very questions we have just begun to ask. Leading this charge is the Europa Clipper, a spacecraft built for one purpose: to determine if Jupiter's icy moon has what it takes to support life. It will not land, but will perform dozens of close flybys, mapping the ice shell in unprecedented detail and using its powerful instruments to analyze the composition of those faint, sporadic plumes. It will essentially taste the moon's hidden ocean from orbit, searching for the chemical fingerprints of a habitable environment. This is not a distant dream. The Clipper is being readied for its journey, a mission that will transform Europa from a blurry image into a world we know. Beyond Jupiter, the ice giants call. After decades of neglect, scientists are actively designing orbiter missions to Uranus and Neptune. These would be the first spacecraft to circle these sideways worlds since Voyager 2's fleeting flyby. An orbiter could spend years mapping Uranus's chaotic magnetic field, studying its bizarre weather, and investigating the internal structure that produces such profound tilt. At Neptune, it could watch the birth and death of great dark spots in real time and conduct detailed observations of its volatile moon Triton, perhaps even confirming the existence of those nitrogen geysers. These missions would rewrite our understanding of planetary formation, revealing why these two blue worlds, so similar in size, have evolved such profoundly different personalities. Our vision will also leap beyond the planets themselves. Next-generation space telescopes with mirrors far larger than Hubble's will peer into the Kuiper Belt with stunning clarity. They will not just find more dwarf planets, they will study their atmospheres, map their surfaces, and perhaps even discover that hypothetical planet 9 by sensing its gravitational tug on the background stars. These observatories will turn points of light into worlds, giving us a complete census of our solar system's final frontier. And for the most daring missions, engineers are sketching concepts for probes that would do the unthinkable. Imagine a vehicle that could dive through the towering plumes of Enceladus, flying through the salty spray to capture pristine samples of its subsurface ocean. Or a submersible robot designed to melt through the icy crust of Europa and explore the alien abyss below. These are not science fiction, they are the logical next steps in a quest that has just begun. The age of discovery in the outer solar system is not ending, it is accelerating. Every strange event we have uncovered is a signpost pointing the way for the explorers of tomorrow. What will they find when they finally arrive at these distant, dynamic worlds? And how will their discoveries change our story forever? This grand tour of 30 strange events reveals a solar system teeming with beautiful chaos. We have witnessed geometric storms etched into the atmosphere of a gas giant, and felt the subterranean warmth of icy moons that spew their oceans into the void. We have traced the ghostly scars on a doomed moon and decoded the silent gravitational whispers that hint at a hidden world. These are not anomalies in a dead wasteland, but the normal, vibrant functions of a dynamic and living cosmic neighborhood. The outer solar system is a frontier of constant change, a place where the rules of physics paint with a bizarre and wonderful brush. Our journey is far from over. New missions are already being built to sail these dark seas, to fly through alien geysers and orbit sideways worlds. The greatest discoveries are still ahead of us. So keep looking up and keep wondering. Follow the data as it streams back from robots at the edge of human knowledge, and let your own curiosity be the fuel for the next great exploration. Tell us which of these strange events captured your imagination the most. Was it the silent hexagon of Saturn, the captured rebellion of Triton, or the hidden ocean of Enceladus? Share your thoughts in the comments below. These distant phenomena do more than just satisfy our curiosity. They quietly dismantle our cosmic solitude. The realization that a small, icy moon like Enceladus possesses all the ingredients for life fundamentally challenges the idea that our planet is a special, isolated oasis. We are not living in a unique sanctuary, but on one world among countless others, many of which may also host the very chemistry that sparks existence. This is a profound shift in perspective, moving us from the center of a biological universe to a single participant in a much grander, potentially living cosmos. Every unexplained event, from the wandering poles of Mars to the transient storms of Neptune, pushes the boundaries of science itself. Our models of planetary formation, of geology, and of chemistry are constantly being rewritten by these discoveries. We are forced to invent new physics to explain the hexagon on Saturn and to reconsider the very definition of a habitable world when we find warmth in the absolute cold. This exploration is not merely about cataloging strange sights. It is a fundamental re-evaluation of what is possible. The outer solar system acts as a vast laboratory for testing the limits of our knowledge, proving that the universe is far more inventive, more dynamic, and more mysterious than we ever conceived from our tiny vantage point. What does it mean for our future if the building blocks of life are not a rare miracle, but a common outcome of cosmic evolution scattered on moons and dwarf planets across the darkness? The greatest discovery may not be a new world, but a new humility, and with it a boundless inspiration to keep searching.